Section 6.4, binomials containing radicals. So hopefully you have done the 6.3 homework or you're in the process of doing it. Today we're going to build upon that and deal with binomials with radicals in them and how to simplify them. So how do we simplify products and quotients of binomials that contain radicals? So you can multiply binomials with radicals just as you would multiply any binomials. So you're going to have to use FOIL and then combine like radicals. So we combine like radicals today in class. You're going to use that knowledge and apply it to what we're doing in section 6.4. So example 1, we have 2 root 2 times the quantity root 6 minus root 3. Remember, you can distribute this to the terms inside the parentheses, and you multiply whole numbers with whole numbers and radicals with radicals. Since there are no radicals inside, or excuse me, there are no whole numbers inside, we just multiply the radicals together, and you get 2 root 12 minus 2 root 6. Now we can simplify the 2 root 12 into 2 times square root of 4 times 3. We can factor out the 4, and you end up with 4 root 3 minus 2 root 6. This isn't anything different than what we did today in class. Now, today this is going to be new. The conjugate. Expressions of the form a root b plus c root d times a root b minus c root d are called conjugates. If you can see what we're having here, it's basically a difference of squares. You have an a plus b times a minus b. And it's a difference of squares special polynomial. If you multiply these together using FOIL, you get a root b quantity squared minus c root d quantity squared, which simplify to a squared b minus c squared d. And as you notice, when you do that, you get rid of the radicals. And as you also know, we can't have a radical in the denominator, it being one of these 7 deadly algebraic sins. So we can use these conjugates to rationalize or get rid of the radicals from denominators with binomials that have radicals in them. So once again, these are called conjugates. You have a root b plus c root d times a root b minus c root d. These letters might be a little confusing, and when we use actual numbers, it'll probably be easier to see. So, for example 2, we have a simple binomial with radicals, 4 plus root 3 times 4 minus root 3. And just like you did when we had x's and y's, you are going to use FOIL. If you do that and you simplify, you use the difference of squares. 4 squared minus radical 3 quantity squared. That's 16 minus 3, or 13. So 4 plus root 3 is the conjugate of 4 minus root 3. By multiplying them together, you get rid of the radical and you get a whole nice integer. Alright, let's move to example 3. We have 3 root 5 minus 5 root 3 times 3 root 5 plus 5 root 3. And again, you can see these are conjugates. A minus b times a plus b. So we can just do an a squared minus b squared. So we have 3 root 5 squared minus 5 root 3 squared, which means this is 9, 3 squared, times 5, which is 45, minus 5 squared, which is 25, times radical 3 squared, which is 3, which is 25 times 5, or 75. So 45 minus 75 is negative 30. So again, when you have conjugates, your radicals should disappear, and you can just use the a squared minus b squared format to simplify the difference of squares. Now, we do not have a conjugate. You will have to use FOIL. 5 root 3 times quantity 3 plus 2 root 3. So you can use FOIL. So let's do 15, that's the first term, plus 10 root 3, that's the outer term, minus the inner term, which is negative 3 root 3, minus the last term, which is negative 2, times square root of 3 squared, which is negative 2 times 3, or negative root 3 times 2 root 3. Okay, so let's put that all together. You get 15 minus 6, which is 9. We can combine these two like terms, 10 root 3 minus 3 root 3, which gives us 7 root 3. So again, when you have two binomials with radicals, use FOIL just like you did when we had x's and y's to simplify the expression, and then combine like radicals and like terms. Now we have a square, 4 root 2 plus root 3 quantity squared. Now you can use FOIL, Or you can use the same thing we did before, which is a squared plus 2ab plus b squared. So in this case, a is 4 root 2. 4 root 2 quantity squared plus 2ab, so there's your a, 4 root 2, times b, which is root 3, plus root 3 squared. So all I'm doing is using the a plus b quantity squared equaling a squared plus 2ab plus b squared. This will save you the effort from doing FOIL. Now at this point, you just basically simplify everything. So this is 32. 4 squared is 16 times radical 2 squared, which is 2. That's 32. We have 8, 2 times 4 times root 6, which is radical 2 times radical 3. Finally, plus 3. Radical 3 squared is 3. And simply we get 35 plus 8 root 6. So you can use your special trinomials, a plus b quantity squared, a minus b quantity squared, and do it that way instead of using FOIL. Alright, now we have example 6. We have two fractions. Now when we have fractions, you multiply the numerators together and you multiply the denominators together. So we have a conjugate here with radical 2 plus 3 times radical 2 minus 3. So we can express that as radical 2 squared minus 3 squared. Remember, conjugates will have a squared minus b squared. 3 times 2 is in the denominator, so that becomes 6. Now let's simplify the expression. Radical 2 squared is 2. 3 squared is 9, so we have 2 minus 9 over 6, which simplifies to negative 7/6. Alright, now we have a radical in the denominator. Example 7, 2 root 3 over 1 plus root 3. The way to get rid of the radical is to multiply the denominator by its conjugate. So the conjugate of 1 plus radical 3 is 1 minus radical 3. So we have to multiply the top and bottom by the same thing. This will allow us to get rid of the radical in the denominator. So let's put that together, and you're going to have to use FOIL on the top to simplify that expression. So we have 2 minus 2 root 3, which is the outer, plus radical 3, which is the inner, minus radical 3 squared, which is 3. That's the last term. In the denominator, we're going to have a squared minus b squared, so 1 squared minus radical 3 squared, or 1 minus 3. Now we just combine like terms, and you get negative 1 minus root 3 over 2, and you can split that into two fractions, or you can just get rid of the negative sign. So you get 1 plus radical 3 all over 2. So to solve these problems with a binomial with a radical in the denominator, you must multiply the top and bottom by the conjugate. If this were 1 minus root 3 on the bottom, you would multiply it by 1 plus root 3. If this were 2 plus root 3 on the bottom, you would multiply the top and bottom by 2 minus root 3. But remember, whatever it is, look at the denominator, multiply by the conjugate. Example 8, 1 over radical 5 minus 1. Again, with a binomial and a radical in the denominator, you must multiply by the conjugate. So go ahead and try to do this one yourself, and then restart the video when you're ready to check your answer. So you're going to have to multiply the top and bottom by radical 5 plus 1. This will eliminate the radical in the denominator, so this becomes radical 5 plus 1 over a squared minus b squared, or 5 minus 1. And your answer is simply radical 5 plus 1 over 4. Example 9, root 5 plus root 2 over root 5 minus root 2. Again, you need to find the conjugate of the denominator, multiply the top and bottom by that conjugate, and then simplify. So what's the conjugate of radical 5 minus radical 2? Whatever it is, multiply the top and bottom by that amount, and let's solve. Go ahead and try that, and then come back when you're done. Alright, so the conjugate of root 5 minus root 2 is root 5 plus root 2, so we're going to multiply the top and bottom by that amount. You happen to have a root 5 plus root 2 squared, so you can use the a plus b quantity squared, and you get 5, which is radical 5 squared, plus 2 times radical 5 radical 2, which is 2 root 10, plus root 2 squared, which is 2. So that's a squared plus 2ab plus b squared. In the denominator, you have a squared, which is 5, minus b squared, which is 2 squared, radical 2 squared. So you have 5 minus 2 in the denominator. Combine like terms, you get 7 plus 2 root 10 over 3, and you're done. So for these problems, they're not super difficult. You just have to follow the approach. When you multiply binomials together, if you don't have a difference of squares or some special trinomial, use FOIL. If you have a radical in a binomial in the denominator, multiply it by the conjugate, and that'll eliminate the radicals. But make sure you multiply the top and bottom. Alright, the last thing I want to do is make sure that we know what the conjugate of each of these values are. So you can do these orally, you don't have to write these down just to check your answer. You can even do these in your head. First, we have radical 5 minus 3. What's the conjugate? Radical 5 plus 3. Next, we have 2 plus radical 2. The conjugate is 2 minus radical 2. You notice that the only difference is the sign. Next, radical 7 plus 1. The conjugate is radical 7 minus 1. Radical 2 plus radical 3. Conjugate is radical 2 minus radical 3. Radical 5 minus radical 2, and the conjugate is radical 5 plus radical 2. So if you can do these conjugates, just remember to multiply the top and bottom by this amount in a fraction, and you'll have no problem with section 6.4. If you have any questions, post them on the Facebook page. For now, that's it.